Hello, this video will cover basics of matrices, and the video is intended for NCBM 0114, and I believe we're on week 13. So we're going to write down some definitions first. We're going to be filling in the blank to complete the definition. And so the first thing we have is that a matrix is a rectangular array of numbers within brackets. And you've seen them, they're like square brackets. Now, we call it rectangular because even though some matrices are square, squares are still rectangles. Then we have each number in a matrix is called an element of the matrix. Then we have, if a matrix has n rows and m columns, just to generalize, it could be any number. It is called an n by m matrix, or sometimes we write it this way, n by m. So the size or dimension, that's what we call it, is given by the number of rows and the number of columns. So let's just give it that way, by the rows by columns. Okay, now for 5, you have a matrix with n rows and n columns. It's called, since we have the same number of rows and the same number of columns, it will be an n by n. So we call that a square matrix. Okay, a matrix with only one column, it's called a, I'm not really sure, I'm gonna just put the best of my guessing here. I'm gonna say column matrix, but this one's also represent vectors, kind of like the ones you see in physics. Now, 7 is a matrix with only one row. It's called a row matrix. That's all I can think of right now. Then we have the position of an element. Remember, element is the numbers inside the matrix, is given by I, lowercase I, comma, j, where I is the row and j is the column. Okay, so right here on example 1, we have this matrix, and by the way, we use uppercase letters for those, and the dimensions of the matrix is 3 rows by 3 columns. So we call it 3 by 3. So now we use the little subscripts that you see here to determine the address of each element or each number inside the matrix. So if this says A sub 22, not 22, but 22, that means we want the number that is in the second row and second column. So that will be second row, second column, it will be here. So that will be 4. Then for the next one, we're going to need the element that is in the third row and first column. And so that will be third row. By the way, rows are horizontally. So third row will be in first column, that will be here, the number -3. Then the next one, it's going to be first row, first column. I'm sorry, first row, third column, so it will be -2. And then the last one that we have here, it is second row, third column, so that will be second row, third column. And so that's just to determine what numbers go where. Now, we have different matrices, can be used for several things. We could use them to solve systems. In fact, they're also used in every picture, every electronic picture is, every pixel represents a number. And so every change that you do to a picture, whether it's with Instagram, Photoshop, or any other software, you're actually altering the numbers. Another pretty good contribution of it is Netflix, for example. They're used to compress and decompress large files. Also, facial recognition is done with matrices. So one of the ones here that we study is how to solve a system of equations. And for that, we have different types of matrices. So one of them is called the coefficient matrix. And so that talks about the coefficients that you will have in a matrix. For example, here, we don't know what that number is, but we call it A11. And then we don't know this coefficient, but we call it A12. And then we move to the second row, and that will be A21. And then we have A22. Then for the constant terms, we still put them here on the right side, K sub 1, and then we have K sub 2. The line is just representing the equal sign. By the way, this is wrong. This should be the augmented matrix. Sorry about that. In fact, let me just get in a different color. So if we use, oh, I lost it. Okay, so let me do it again. Coefficient matrix will just have the coefficients that we see here. So it will just be a 2 by 2. So A11, A12, A21, A22. Now for the constant matrix, that will be this one here. So it will be just 2 row, 1 column, and that will be K sub 1, K sub 2. Now for the augmented matrix, that's the one that will be both of them together. So that's the one that you will have to write that line in the middle, the constants on the right side of the line, because that's the equal sign. And then the coefficients go on this side. Is Mr. Ahmad allowing you guys to use a calculator?
Yes, but
okay.
A scientific one, not a graphic calculator.
Oh, okay. All right. So then, for example 2, it says write the following system in matrix form. So that is one of the things to do to translate a system into a matrix. Now here it's not specified which type, so I'm just going to assume they want the augmented one, okay? And so that will be the coefficients of the x are -8, of x sub 1 is -8, and then of x sub 2 is a +3. So instead of solving for x and y, they're changing it to x sub 1, x sub 2, okay? And then the constant term is here. And then for the next row, we'll have a 6, we'll have a 5, and we'll have a 13 right there, and we're done. Now, to write the next one, same thing. So coefficient of x sub 1 is 5, and then the coefficient of x sub 2, we have negative, so it's -1, and then the constant is 10. On the next equation, we don't have an x sub 1, so we have to put a 0. And the next one is a 3, and then we have a 21 here. So that's it just for writing the matrices. Now, we're going to do the opposite of that. So now the instructions are asking us for us to write a system based on the augmented matrix that we have here. So it says to use the variables x sub 1 and x sub 2. However, for your homework, it could be x, y, it could be x, y, z. So just make sure you read what they want you to do there. So in this case, if this column represents all my x sub 1s and this represents my x sub 2s, I will say 2x sub 1 plus 5x sub 2 is equal to 7. For the next row, it's going to be 1x sub 1 plus 4x sub 2, and that is equal to 9. And then for the next system here, we're going to have, let's put the constant terms here. And then we have, oh, I'm just doing the same thing. What am I thinking?
Yeah. Yeah.
Yeah, like I was just going back in a circle.
Yeah. You have to write
The system, right? So then instead of a matrix, let's put them in a system. Okay, so we need the equals here. So this will say 1 x sub 1 plus 0 x sub 2. And then here we have 0 plus 1 x sub 2. Now here the zeros are unnecessary, right? So we could just say x sub 1 equals 4 and x sub 2 equals 3. Okay? All right, so now let's go to the next page. And so to do this thing, and we have two actually. One of the things that we use to solve systems of equations with matrices, one of those is called Gaussian elimination. And then the other one is called Gauss-Jordan. And so the first one was created by this guy with the last name Gauss, Carl Friedrich Gauss. So on your calculator, you do have this form that says REF, which stands for reduce, or no, row echelon form. Now, then the second method, Gauss-Jordan, is kind of like an update of the first one. So this other guy with the last name Jordan, I can't remember his first name, kind of like perfected the method or made it like improved it. I call it the version 2.0. So this RREF stands for reduced row echelon form. Okay, now to get to those things, well, let me tell you how they will look. For Gaussian elimination, what they want us to have is ones in the main diagonal and then zeros below it. Then whatever you have everywhere else, it could be any number, so I'm just putting stars. And when you do this, after you do this, you will have to use back substitution. Now for the Gauss-Jordan, I do personally like it better because you don't have to use back substitution at the end. So you have ones in the main diagonal, zeros everywhere else, and then the numbers that you get here at the end, those are your solutions to the system. Now, for us to be able to get to that point, we have to rely on the elementary row operations that we have here. So let's look at three of those. We can have two rows being interchanged. So if you see here, it could be an example like interchange row 1 with row 2. I personally don't like to use that a lot because sometimes I make mistakes, but it is a valid row operation. The next one, it says a row can be multiplied by a non-zero constant. So right here, the non-zero constant is k. So we can multiply, let's say, 2 times R1, and then we want it to become a new R1. So the arrow kind of tells you like replaces. Then for the third statement, we have a multiple of one row can be added to another row. So this is when you multiply and then you add to another one. So let me give you an example with numbers here. So we could have 2 times the first row and then add it to the second row, and that will lead to a new R2, a new second row. So those are the row operations. So now we're going to go ahead and use them. So right here, we have just some easy ones. And the very first one is telling us, we're going to use this matrix, first of all. It's telling us to take the second row and multiply it by 1/2. All right? So when this happens, it's important to keep in mind that nothing is happening to your first row. So that's what I like to do, just copy what I'm not going to change so I don't get confused. Now I'm just going to focus on that second row. So we have 4 times 1/2 is a 2. -6 times 1/2 is a -3. And then -8 times 1/2 is -4. Okay? And that's it for that one. Okay, so let's move on to the next one. And it says, multiply the first row times -2. Okay, so let's do that. Well, let's go ahead and copy second row first because we're not going to change anything to it. Okay. And actually, you know what? I think it wants us to do like continue it. So this will be like the next step. So let's, instead of going back to the original matrix, let's go back to the previous one. Okay.
Okay. The one we already did?
Yes. The one from 4A. Yeah, let's do that. Okay. So then from this one, from this matrix here, okay? So we're going to take row 1 and multiply it by -2, sorry.
Okay.
So this one here, and by -2, so -2, 6, and -4, right? And then we're going to replace that R1 with that. Yeah. So -2, 6, and -4. And then the other one, let me copy it from the previous one. It was 2, -3, and -4. Okay. Now, right here on this one, it says to add row 1 and row 2. To produce a new row 2. So if we add -2 plus 2, we get 0. And then 6 minus 3, we get 3. And then 4 minus 4, -8. Then the first row is not changing, so I'm just going to copy the previous. And then lastly, they want us to multiply the first row by -3. So that's going to be -3 times -2 is +6. -3 times 6 is -18. And -3 times -4 is -12. And then they want us to add R2 from here. So we have 0, 3, -8. And if we add those numbers, we'll get 6, -15, and -20. And that is our new R2. So that goes here. R1 is the same as the previous one. Okay, so I really don't see the purpose of this exercise, but yeah, we just did the row operations. So we were not really trying to get the Gaussian or the Gauss Jordan. We were just practicing, kind of like a warm-up. Okay. So now for this last one, we're going to go ahead and we're going to solve it, okay? And this is the last thing we'll do today. Now, I just want to solve it because I've been told I'm pretty good at this, okay? So first of all, we construct the augmented matrix, all right? So 1, 2, -3, and then we're going to have here negative 28. Then we're going to have 0x, 4y, 2z, and then a 0 here. Then we have negative x, so negative 1, plus y, so positive 1, and then negative z, so negative 1. And then we have a negative 5 here. Okay, so now you already know that what we're trying to achieve is this here. This is our goal, okay? So, however, we must work in order, and we got to do it this way. First column, the first thing we do is the 1, and then the 2 zeros. Once we accomplish that, we can move on to the second column, but the first thing we do is the 1, then the 2 zeros. And then after that, our last step will be to move on to the third column, make this a 1, and then the 2 zeros, okay? So I'm going to tell you this. Anytime you want to make a 1, well, I'll tell you that when we get there. So let's look at our first column. We already have the 1. We already have a 0. Now we just need to make this negative 1 into a 0. All right? So because this is our 1, we call that our leading row. So I'm going to use R1 times. Now let me ask you something. If you have negative 1 and I tell you make a 0 out of it, what would you do?
Multiply it by...
Oh, well, yeah, that's true. Multiply by 0 will work. But remember, in our row operations, we cannot multiply by a non-zero constant. So think about addition. What would you add?
Oh, a 1, a positive 1?
Correct. And so these two numbers are called additive inverses. So anytime you want to make up a 0, you rely on the additive inverse of the number you want to make a 0. Okay? So in this case, we use R1 times positive 1, and we're going to add it to R3 to produce a new R3. All right? So first, let's copy whatever we're not modifying. So we have 1, 2, negative 3, and then here we have negative 28. For the second row, we have 0, 4, 2, and 0. Now, to do this process here, R1, we're taking it from here, times 1, so it's the same row. And then we're going to add it to R3 from here, okay? So it's going to look like this. Okay. 1 minus 1 is 0. 2 plus 1 is 3. Negative 3 minus 1 is negative 4. And finally, negative 28 minus 5 is negative 33. Are we okay with that?
Yeah.
All right. Now we're done with the first column because you can see we already have vertically, right? 1, 0, 0. So we move on to the next column. And the first thing is to make this 4 into a 1. Now, to make 1s, I already told you what to do to make zeros, right? You use additive inverse. Now, to make 1s, let me ask you this. We have a 4 over 1, and we want to multiply by something so that we get a 1. What will that something be? So I want to...
So it would be 1 over 4?
Very good. The reciprocal of it, yes. And so those things are called multiplicative inverse. So anytime you need to make a 1, you rely on the multiplicative inverse. All right? So we're going to do that to now to the second row. And I'm going to be looking at the second row from here. All right? And that's going to be 1/4 times my second row. So before we proceed, let's copy what we're not changing. So go ahead and copy the first row from the previous step. 1, 2, negative 3, and negative 28. And then our third row, 0, 3, negative 4, and this is a negative 33. Now, if I multiply my row 2 times 1/4, we said it will be 0 times 1/4, still 0. 4 times 1/4, 1.
1.
2 times 1/4 is going to be like 2/4, but it turns into 1/2, all right?
Mm-hmm.
And then 0 times 1/4 is still 0. Okay, so now we're done with that one. Now our next step is to make this to a 0. Okay?
Okay.
So now we're going to use R2 as our leading row because that has a 1. And the additive inverse of 2 is -2, correct? And then we're going to add R1. So go ahead and copy the ones that we're not changing. So let's go ahead and copy R2. And then let's go ahead and do this operation here. So if we take R2, and I'm going to write it here on the side, okay? You could always use like scratch paper for that. R2 times -2, right? So it's going to be -2 times 0, 0. -2 times 1, -2. And then -2 times 1/2 is going to be -1. And then -2 times 0 is going to be 0. Now we're going to add R1 from this previous matrix. So that is 1, 2, -3, and -28. So if I add those numbers, I will get 1, 0, -4, and -28. So that will go here. 1, 0, -4, -28. And we're almost done. We're starting to see the light.
So we
So
have
then,
to make the 3 a 0 too? The one at, I
correct,
mean,
that will be the very next step. So let's do that. So tell me now, which one is our leading row at this point?
the
So we're right here, the one that carries the 1, right? So if we're working in second column, second row will be the leading row. So for that reason, we're going to use R2 times, what is the additive inverse of +3?
3 over
Negative,
-3.
yes. And then we add that to R3, okay? So let's copy what we're not changing first. Go ahead and copy your first row.
1 0 -4 -28.
And then copy your second row.
0 1 1/2 0.
And now let's do that, this multiplication here. So we take row 3 from here, okay? No, my bad.
Take the second row and then multiply it.
Yes. Multiply by what?
-3.
Very good. So 0 times -3, still 0. 0
0.
times 1. I'm sorry,
0.
-3 times 1, -3. And then -3 times 1/2, -3 halves. And then -3 times 0 is 0. Okay. And then we need to add the third row from here, right? Okay, so 0, +3, -4, and -33. Okay, so the result of this, I'm going to write it here, okay?
0.
So we have
0.
0, 0. Now, with the fractions, you might want to get like some scratch paper or something. So we could say -4 over 1 minus 3/2. So -4 over 1 is the same as -8 over 2. If you multiply top and bottom by 2. And we do that so that we can subtract the -3/2. So that will give us -11/2. Okay. And then lastly, we have the 0 minus 33, so we get -33. Go ahead. You have a
What?
question?
Oh no, I was just repeating what you said.
Okay. All right. Now we're done with the first two columns. We're almost done. So now for this column, the first step is to make this one a 1. All right. And that's going to be kind of easy. R3 times. Now, we wanted, remember what we talk about multiplicative inverse, correct? So
Yeah,
we want to use reciprocal.
the 2 over 11.
Yes, but we want to get positive 1. So if this is negative, we're going to have to put a negative here as well. Okay?
Okay, because negative times negative.
Positive, yes.
Okay.
So we get this, and we'll have 0, 0. At this point that you're done with the first two columns, you could just copy them because the numbers won't change. And that's the reason why we follow that order, so that whatever we did before doesn't change with the new.
Yeah, because when we were doing it with Ahmad, I think he did it some other way. Like he was confusing me about because he was going like back and forth between the numbers. Like
Yeah,
he was doing this order. And I think
yeah.
it
It's because, you know what? Sometimes professors like to interchange rows. And to me,
yeah,
that makes me get confused. So I prefer to just use the additive
like
inverse and the multiplicative inverse.
yeah, we did like interchange row 1 and 2, and then I got confused which was which, and then
Yeah, I know he was actually my professor. So yeah, I know
okay.
he likes to interchange rows. Okay, so let's do this part right here. Remember, we still need to multiply negative 33 times negative 2 over 11, right? Step here.
Hmm.
And so I wrote them down here on the side because, you know, sometimes you just need that spread paper. So we have negative 2 times negative 33 is positive 66. And then 11 times 1 is just 11. So the number that comes out of here is just 6. You see? And we have our first solution. Now, over here, let's just copy what we had. And we're almost there. What are the last two things that we have pending?
Making those 2 zeros.
So we want to make
The negative.
the negative 4 and the 1/2, right?
Okay.
All right, so let's do that. That will be our last step, and then we'll be done for today. I'm trying to make a little bit more room.
Okay.
Okay, so let's go ahead and copy the row that we're not changing, okay? So that will be our leading row, this one right here. 0, 0, 1,
1.
and 6. Okay, now we want this negative 4 to turn into a 0. I'm going to have to make more room here. Okay, and so we're going to need the leading row, which now is R3. And we're going to multiply it by the additive inverse of negative 4. So what will that be? Positive
4.
4. So remember, to make zeros, you want additive inverses. And then we're going to add to row 1. So let's just go ahead and copy row 2 because we're not changing it yet. Okay. So 4 times R3 right here. I'm going to multiply that row by 4, okay? 0, 0, 4, 24. Now we need to add row 1 from this previous step. So that's going to be 1, 0, negative 4, negative 28. And if we add vertically, we get 1, 0, 0, negative 4. And that will be our new R1. All right. Now we just got one more, I promise. So let's copy R1. Let's copy R3. Now our leading row, it's still R3, okay? So we're gonna need it here, R3 times. And we need to make this 1/2, or this 1/2, into a 0. So we're gonna use the additive inverse, which is negative 1/2, okay? We're gonna multiply it times R3, and then we're gonna add R2. Okay, so this is how it's gonna go. 0 times negative 1/2 is still 0. 0 times negative 1/2 is still 0. 1 times negative 1/2 is negative 1/2. And then 6 times negative 1/2 will be negative 6/2, which is negative 3. Now from there, we still need to add R2 from this previous step, and that will be 0, 1, positive 1/2, and 0. So if we add those numbers, we will get 0, 1, 0, negative 3. And that will be our final answer. So I know it takes a while, but practicing makes it faster. Now, once you have your ones in the main diagonal, you know this become your solutions to the system. So we have that. What variables do we use? We used x, y, z, right? So we will have that, and I have no more room here, but I'm going to write them here. 1x is equal to negative 4 based on this. 1y is equal to negative 3, and 1z is equal to 6. Okay? And so we are done with this one. Do you have a graphing calculator, correct?
No, I
Or
have
no?
a scientific.
Oh, okay, okay. So if you get a hold of a graphing one, there's a way that you can check your work. I'll send, I don't know if I already sent it on Remind, but if I didn't, I'll send it to you. I'll check on the calculator, okay? So
Okay, thank you.
let's try to next week to see what you're struggling with, and then we could address that before you have your first exam. Okay? I mean, your last exam.
Yeah.
Okay. All right. So stay in touch. Okay.
Yeah, thank you. Okay, thank you. Bye-bye.
Bye.